Hello, how are we doing today? Let's get started. In this problem, where my cursor is, we have square root of 3x times the square root of 4x times the square root of 6x. There's a few ways you can do this problem. Here's the way I'm going to do it this time. We can bring all this together. So 3x times 4x times 6x is when you multiply 3x times 4x times 6x, you get 72x cubed. Now it's all inside the square root because what we really have is the square root of 3x times the square root of 4x times the square root of 6x. So that's the square root of 72x cubed, or aka radical 72x cubed. So now remember, guys, x cubed, we chunk it up into x squared times x, and that x squared is going to come out as x to the 1, and x stays in. And if you're rusty from the last video, what we do is the step that I sort of skipped here, and I'll unskip it. Well, excuse me. So we have that. So I turn x cubed into x squared times x. And remember, you divide this 2 by this understood 2 right here, and you get 1. So x to the 1 comes out. And remember, all variables are assumed to be positive. That's going to be true throughout this video and many videos that deal with radicals anyway. So this positive x comes out. We're assuming all variables positive. This x stays in. Now, we still got to deal with 72. All is not well yet. You know, we're on the right track. Now, the trick now is to break off 72x here as 36 times 2x here. But now but I did that because we want the biggest perfect square that goes into 72, and that's 36. So here's the 36. So 36 times 2x. Now that 2x isn't coming out, but that 36 comes out. The square root of 36 is 6 itself, and that's 6 radical 2x. So there's that. Now another approach, the approach I took here was fine. It may not be the most economical. A second approach that we can take is, and in fact, in a minute I'll show you something economical. Let's look at this one. Radical 3x times radical 4x times radical 6x, and by radical I mean square root. So you can break this all up. Radical 3, radical x, radical 4, radical x, radical 2, radical 3, radical x, all multiplied mutually. But hey, you know what? This radical 4 is 2. Remember, the square root of 4 is 2. Okay, so and then that's this 2 right here. I'll go ahead and perform the square root. Remember, all variables positive. Radical x times radical x is x itself, so I go ahead and perform that. But we've still got this dangling radical x that has nobody to go with, so he just stays here, right here. Now we've still got this radical 2 that's not going to simplify. He just stays here. And that's pretty much it. So what we've got, now 2 times 3 times x is 6x. Rad 2 times radical x is radical 2x. There's a bunch of ways you can do this. There's several different combos. Let me go back up here and show you a more economical approach. What I did here is correct, but perhaps not the most economical approach. What would have probably been more economical is to have, just from the very get-go, to have, let's do this. There's like a billion different ways to do this problem, well, figuratively speaking. Now, but anyway, the square root of 3x, we can't do much with that. The square root of 4x, even though the x can't come out, the 4 can come out as a 2. So that's 2 radical x. Now, we can't do much with the square root of 6x. Yikes, about tapped the wrong thing there. So let's just leave that be. And oops, let's go in, tap that. So now what we've got here, now that 2 is just going to stay out. And that 3x times x times 6x, yeah, that's 18x cubed. You know, we're not home free yet. So, but now the thing to do now is to, from that 18x cubed, take out 9x squared, and then that's going to be 9x squared times 2x. You can put a I use parenthesis multiplication. You can do just put a dot and then 2x or whatever. There's that. Now, guys, 9x squared, the square root of 9x squared, assuming all variables positive, is 3x. So that 9x squared comes out as a 3x. Now, it's going to multiplicatively hit that 2 that was already out there. So we got 2 times 3x times radical, the 2x that did not get to come out. And then, now by associativity, 2 times 3x, we can multiply that 2 and that 3 by associativity, and we get 6x. So that's 6x radical 2x, with the 2x inside, whereas the 6x is outside. So there's that. There's several ways to do these, but you get the idea in the big picture. Again, as always, we're assuming all variables are positive. But anyway, there's that. So let's scroll on down to the next page. Now, here's a bit of a change of the guard. Let's say we use FOIL or the distributive property for multiplication. Like if you distribute radical x through these parentheses here, radical x, by radical I mean square root. So radical x times 1 is radical x. Now the plus, now the square root times the square root is just x itself. In other words, radical x times radical x is x itself. Remember the distributive property. You multiply both of these dudes on the inside by this guy on the outside. Okay. Now, if we do FOIL distributive, you remember, let me explain what happens here. I skipped a step here, and I justified it by difference of squares, and that is what we're doing, but let me show you what's going on under the hood here. So, you remember, if you do a minus b times a plus b, that's a squared minus b squared, okay? So if this is a and this is b, we'd have a minus b, and here's a plus b equals a squared minus b squared. Now, guys, 1 squared is rather boring. I'll write it as 1 squared, but that's just 1. But anyway, a squared minus b squared, 1 squared is 1 itself, and then minus. Now, if you square the square root, that's just x itself, and we're assuming all variables positive. So that's just x itself. And then these things come in handy by and by. And then again, a minus b radical x times a plus b radical x. And now that's going to be, now let me justify here in the middle what's going on. What we've got is we've got the a squared, that's pretty straightforward. But now then the second guy we have to use a parenthesis. We are squaring entity b radical x. So we got a squared minus entity squared. A minus entity times a plus entity is a squared minus entity squared. But now, guys, the product of the squares is the square of the product. So we're assuming all things positive. A and B don't really have to be positive, but oh well. So now a squared minus, now if you remember b radical x, if you square that, that's just going to be b squared rad x squared. But guys, remember, rad x squared is just x itself. So that's just x itself. Like if we would have had bc squared, bc parentheses squared, that would be b squared c squared. Where if the b and the c are both in parentheses and then you square it, you'd get b squared c squared. But there's that. Now this comes in handy by and by. This is an example called, this is a conjugate as well. You can think of this guy right here and this guy right here as being things called conjugates. You negate the middle but not the first term. They're not negatives, they're conjugates. Don't worry about the vocabulary right now. Don't get too hung up on that. Again, a minus b times a plus b. You square the 2. Let me insert the step that I skipped there. You square the 2 and you square entity, the other guy. So you're going to square the other guy there. Now, square the 3, you get 9. Square the radical x, you just get x itself. That's how this second guy came to be. So there's that. Now, again, here is a minus b, a plus b. And again, I'll show you the step that I skipped. Now, this time you're squaring not just 2, you're squaring radical 2. Which is just going to be 2 himself. If you square the radical, you just get the original thing itself. And then minus entity squared. Excuse me there. Can't type anymore. Sorry about that. So a squared minus b squared. And here's a, here's b, here, or a minus b. Here's a plus b. Where again, this is a, this is b. So a squared minus b squared, that's 2 minus 9x. Because the radical x just squares to ordinary x. Okay, so there's that. And now here is an example of a distributive FOIL. You can use distributive or FOIL. Now, let's do FOIL. First, outer, inner, last. 2 times 10 is 20. That's this guy. And then my outer terms would be 2 times 7 times rad x. That would be 14 rad x. And with a positive sign. Everything's positive. Now, negative 3 radical x times 10. That would be negative 3 times 10 times radical x. That would be negative 30 radical x. We have commutativity and all that. And then now negative 3 rad x times 7 rad x. Now the negative 3 times the 7 is negative 21. Radical x times radical x is just x himself. We're assuming all variables positive as always. Now we can combine the two terms in the middle. Positive 14 minus 30 is negative 16. So we have 20 minus 16 radical x minus 21x. And this is correct, but it's good manners and in calculus anyway, and even in algebra, I think it's good manners to put the highest exponent, which is 1, in front, put the half power in the middle, and then put the understood plus 20 at the end. The 20 is positive, so it merits a plus sign right here. It's just good manners. Your professor, he or she might very well take it if you leave it like this, but I want you to have the power and the insight to write it like this, okay? Just whatever your professor prefers is okay, but I would like you to know how to do this and to be able to if you had to, okay? So you could stop here technically, but oh well. So there's that. And then here's just another example of FOIL. 2 times neg 10 is negative 20. That's first. And then outer, 2 times neg 7 radical x is neg 14 radical x. And then inner, I think on the last example I forgot to mention inner and last. I did them, but I didn't really mention when I was doing them. But here's inner. Negative 3 radical x times negative 10 is positive 30 radical x. So that's a plus sign there because you're multiplying this negative and this negative, okay? And last is this term times this term. Now negative 3 radical x times negative 7 radical x. That's positive 21x because these two radical x's combine to make ordinary x. And then combine the two guys in the middle and you'll get negative 20 plus 16 radical x plus 21x. And that's good. You can stop there. But for good manners, I'll put the positive 21x in front, the positive 16 radical x in the middle, and the minus 20 in the end. Just for the sake of good manners. Now let me scroll back up. I was correct a minute ago. I forgot to mention something. You remember when I was doing FOIL, 2 times 10 was the first, 2 times 7 radical x was the outer, negative 3 radical x times 10, that's the inner. That's the guy that gave me the negative 30 radical x, the inner. And then the last was this guy, the neg 3 radical x times the positive 7 radical x, and that the last gave me, upon multiplying, negative 21x. So that's my inner and my last. I wanted to just bring that on home, so to speak. I think, let's stop the video here and I'll move on to the next video. Thank you guys. I'll see you on the next video.